All right, number one. Values for f of x, the parent function. This is worded weird. I fixed it on the test. F of x is the parent function. G of x is a transformed function, right? They're in the same family. Use the table to answer the questions and write a general rule. Ooh, general rule, like we know. That's my f of x equals ab to the power of x. That's my general exponential rule. So in order for us to write that, we need to know what a sub 0 is, and we need to know what r is. If I look at f of x first, what is my r as I'm going down the line of my y values here? I'm decreasing, I'm getting smaller. What am I dividing 25 by to get 5? 5. What am I dividing 5 by to get 1? 5. So what is my r? 1/5. 1/5. Again, we could take 5 over 25. We could take 1 over 5. We could take 1/5 over 1. All of those ratios make 1 over 5. So that's my r, or my b, I guess, in this case, technically. How do I find what a is equal to? Alex, where do I look?
You divide by 1/5 to get a sub 0.
You divide by 1/5 to get a sub 0? Oh, yeah, you could do that. What's an even easier way to figure out what a would be? Ava, what were you going to say?
On the table.
It's on the table. When x is 0, f of x is a, so I know that my a is 1. But like you said, 1/5 over 1/5 gives me 1. So write the equation. F of x is equal to a, which is 1, times b, which is 1/5, to the power of x. That's it. What's my b value for g of x? If I take 3 over 15, what's 3 divided by 15 simplified to? 1/5. Same b value. Is my a value the same?
No.
No. What's my a value on this table? 3. So my function is 3 times 1/5 to the power of x. The question now is g of x a vertical stretch or a vertical compression? What number are we looking at, Gurpreet, to figure that out? We're looking at 3, right? My a value was 1. It became 3. Gurpreet, did we get bigger or smaller? Did we get bigger or smaller from 1 to 3? We got bigger. So is that a stretch or a compression?
Stretch.
It is a vertical stretch. By a factor of 3. All right. Any questions on number 1? Is that what you guys got? Quick show of thumbs. Anybody get that right? Very nice. Number 2, Billy earns money by mowing lawns for the summer. He offers 2 payment plans to all his customers. Pay $100 for the entire summer. Or pay $1 the first week, $2 the second week, $4 the third week, and so on. Do the payments for Plan 2 form a geometric sequence? Give me a thumbs up if you think yes. Give me a thumbs down if you think no. Do those form a geometric sequence? I appreciate the 7 of you dealing with it. Yeah, that is a geometric sequence. Right? Let's set this up as a table. First week, $1. 1, 1. Second week, $2. 2, 2. Third week, $4. 3, 4. What am I multiplying my dollar amount by each week? 2. So what is R? 2. Do the payments for Plan 2 form a geometric sequence? Yes, because why? Who can give me a content vocabulary explanation? Christian? No? It's okay if not. Alex, what did you say?
It does form a geometric sequence because the common ratio is 2.
Perfect. Sounds good to me. Part B says, assume the summer is 10 weeks long. How much would one of Billy's customers pay for all 10 weeks using Plan 2? Ooh. What's the easiest way for us to figure that out? We got to write the explicit rule. If I want to find a value deep in the future, I don't want to use the recursive rule. It's going to make me do this 10 times. I don't want to do it 10 times. I want to do it once. So let's say the summer is 10 weeks long. That means I'm going to find a sub n. Well, what's the explicit rule? Explicit rule says a sub n is equal to a sub 1 times r to the power of n minus 1. I know that a sub 1 is what? 1. Because after 1 week, that's $1. I know that each week my dollar amount doubles, so my r is 2. Now I can find a sub 10. 1 times 2 to the power of 10 minus 1. Well, what's 10 minus 1? 9. So I'm looking for 1 times 2 to the 9th power. What on earth is 2 to the 9th power?
512.
512? 2 to the 9th power? 512 times 1, which is 512.
Yay!
How much would one of his customers pay for all 10 weeks? They'd pay $512. What plan sounds better, plan 1 or plan 2? Plan 1, $100 for the whole summer. Second guy is a taxi, $512. So at what point, how many weeks should a customer choose plan 1? Plane. Does it say plane? I thought I was tripping. This is tripping. Plan 1 over plan 2. Show how you know. Well, how can we figure this out? What's one way, Christian, we can figure it out? You got it. I think you're thinking of the harder way to do it. You forgot what it's called? That's okay. The recursive rule you're talking about? Yeah? We could do that. We definitely could. We could use the recursive rule to extend this table. Right? Alex, what were you going to say? Same thing? Perfect. Let's do that then. 4, 5, 6, 7, 8, 9. I know it's not going to be 10 weeks because that's way more than $100. We're trying to find the point where the plans switch in terms of which one's more expensive, right? So I keep this pattern going and multiply by 2. What's my cost after 4 weeks? $8. What about 5 weeks?
16.
What about 6 weeks? What about 7 weeks? What about 8 weeks? Ooh, we've crossed the $100 mark. So the question is, at what point should a customer choose plan 1 over plan 2? How many weeks? 8 weeks. Obviously, you know, explain it better. I'm not going to write out the whole explanation just so you could write it all down. But you would say a customer should choose plan 1 over plan 2 if they intend to have their lawns mowed longer than 8 weeks in a row. Right? Because as soon as that 8th week comes around, I should have went with plan 1. It's $100 for the whole summer. Definitely don't want to go to 9 weeks or 10 weeks. That's where we're making all the big money, right? So something like that for part C. Does that sound good on number 2? Yeah? Anybody figure that out on their own? Or with each other? Ooh. Okay. Less than I'd hoped. Number 3, this is the easy stuff, right? Hopefully. Hopefully this is the easy stuff. I'm going to zoom in because this is tiny. The test will be full page. Don't worry. There'll be 3 pages, but they'll be full page. Yeah.
For like the little Billy problem, when aren't like the customers paying $4 and then $8, like after like the second week they're paying like $12. So like when they like I don't know, be paying $100 before that 7-week mark? Because they're paying more and more money. They're just paying like that much.
$1 the first week, $2 the second week.
So they
Oh. I see what you're saying. I gotta fix that. That is worded wrong. It shouldn't be worded that way. It should be the total. I see what you're saying. You're saying at 8 weeks it would be 128 plus 64 plus 32. We're not gonna do that. Don't worry about that. I'll fix the wording so it doesn't say that. Good catch though. You're very right. It should say $1 for 1 week, $2 for 2 weeks, $4 for 3 weeks, not each week or whatever it says. All right, number 3. If I have a negative exponent, what do I do to my fraction? Flip it. So 2/7 becomes 7/2s. So 7 seconds, whatever. And the exponent turns positive, right? Alex? Oh, what do I do now? Yeah? Square the top and the bottom. Can I simplify 49 fourths? Nope. That's my answer. Part B. Anything to the 0th power is what? 1. So is my answer here just 1? No. Good catch. 5 times 1 gives me 5. Down here, what's 2 to the 3rd power? 8. What's negative 6 times 8? Negative 48. And what's 1/2 to the 3rd power? 1/2 times 1/2 times 1/2 is 1/8. What's negative 8 divided by 8? Negative 1. You guys got all 4 of those? Yeah. Perfect. We're not going to even talk about it. We're going to move on. Here we go, number 4. Find the common ratio R for each focused geometric sequence. Use R to find the next 3 terms. So what number 4 is asking is use the recursive rule. That's what it's saying. Find the next 4 terms, use the recursive rule. But because these are a little bit easier, we don't need to go through the whole process of writing out the recursive rule and plugging things in and doing the n-1, all that. We can just use our eyeballs. 3, 12, 48. What's my R? 4 times 4 times 4. So what would my next term be after 48? This kind of looks familiar, doesn't it? 192. We did this one, right? We didn't go past 192. What's next? 768, and then
3072. Wait, what?
3072, right? Right. Perfect. So we just keep going a couple more spaces. What's my R in B, though? Negative what? Negative 1/2.
I did it right.
Negative 1/2. What are my next 3 terms? Well, after 15, it's going to be negative 15 over 2, 7.5. Then it's going to be a positive 3.75 or 15 over 4. Does not matter. Hold on. Okay, now it's negative 15 over 8, which as a decimal would be what? Nice. We can do either one. Decimal fraction, I do not care. Everyone good on 4? We got to kick it up a notch. Number 5, explicit and recursive. We went over this a lot. This is easy. First jump is 6 meters. Second jump is 10 meters. Do I know what a sub 1 is?
Yeah.
What is it? 6. How can I find what R is? What fraction can I set up? 10 divided by what? 6. Y2 over Y1 equals 10 over 6, which is 5 over 3. Explicit rule. There's really not enough room here on this one. Explicit rule. A sub n equals a sub 1 times R to the power of n minus 1. Right? That looks right? Okay. Recursive rule. Squiggle. A sub 1 equals 6. A sub n is equal to R 5/3 times a sub n minus 1. Anybody get that, number 5? Hopefully, if you weren't able to figure that one out yesterday after we talked on the whiteboard, that was one of the ones that you were able to figure out. Anybody? Yeah? Maybe? No? Okay. That's fine, too. Number 6, evaluate each geometric sequence given the explicit rule for n equals 4. So all I'm going to do is take n and plug in 4. A sub 4 is 8 times 1/4 to the 4 minus 1 power, which is 3. What's 1/4 to the 3rd power? 1/64. So I have 8 times 1/64, which is 8 over 64, which is 1 over 8. It's not a race. I appreciate your support. Okay. Second one, still n equals 4. So A sub 4 equals 3 times 5 to the 4 minus 1. 3 times 5 to the third. 3 times 125. 375. And we can see here, when looking at these two, that when my common ratio is a fraction less than 1, I get smaller and smaller and smaller, decaying. If my R, my common ratio, is more than 1, I'm getting bigger and bigger and bigger. Growth, right?
How do you keep going in 4?
It gave me n equals 4 right here.
Oh.
Yeah, so we just plug that in. Okay. Number 7, write an explicit rule for each geometric sequence based on the given terms. Perfect. We did this earlier too. 2 points. 3 is 50. 4 is 10. If I want the explicit rule, I've got to go backwards to 1. My R here is 10 over 50, or 1/5. So if I'm multiplying by 1/5 going down the line, what am I multiplying going up the line? 5. The reciprocal of 1/5, which is 5. That gives me A sub 2 is 250, and A sub 1 is 1250. So my explicit rule will be A sub n equals 1250 times 1/5 to the n minus 1 power.
Yikes.
Does that look good, that one?
Yes.
Yeah, I know I'm losing some of you. Please just stay with us. Some of you were lost from the start. That's not my problem. So for the next one, R, again, I'm going to take y2 over y1. Right? Dividing by a fraction is the same as multiplying by its flip, or its reciprocal. That gives me 10/12, which is 5/6. What's my A sub 1? 4/5. It's right there in the point. X value of 1, Y value of 4/5. So A sub n is equal to A sub 1, 4/5, times R, 5/6, to the n minus 1. Couple explicit rules there for you on number 7. Haven't even gotten to the graphing yet. Number 8, turtles growing in a manner that can be represented by the sequence. Given the table of values, determine the turtle population after 6 years. So we're going to fill this out. After 6 years, the turtle population is going to be something. Explicit rule and the general rule. Now, remember, general rule is a little bit different. What do I need to know in the general rule that's slightly different than explicit and recursive? You guys remember? Yeah, Judah? A sub 0. So for here, I'm going to put it off to the side so I remember. I'm going to need A sub 0. So we start out with 5 turtles. The next year, there's 15. How much did I increase my turtle population by? 3-fold, 3 times. So how many turtles are there going to be after 3 years? 45. What about 4 years?
135.
135. 5 years?
405.
4 what?
405.
405. Okay. And then we could do 6 years. That'll give us my answer right here. I'm going to write the explicit rule first. The explicit rule, I need A sub 1, and I need R. Here's my A sub 1. There's my R. T of n, turtle function, my turtle function of n is equal to A sub 1 times R to the n minus 1. I could then do T of 6 to find out how many turtles there are going to be. It's going to be 5 times 3 to the 5th power. 3 to the power of 5 is 243 times 5 is 1215. That's what we would have got going one more step down on our table. Now, the general rule, I got to go one step back. So what can I multiply by 3 in order to give me 5? Alex? Exactly. This is where the general rule gets a little bit tricky, right? So the general rule, a sub 0 here is going to be 5/3 times b, which is 3 to the power of x, just like that. How do you have 5/3 of a turtle?
No idea. Cut the shell.
Well, we're not going to cut any shells off, okay? You can't have 5/3 of a turtle. That's why in some situations, like I said, the general rule, we cannot find what a sub 0 is, or at least we can't have a context to that a sub 0. Yes, we can plug in that fraction and create a functional function, but it doesn't mean anything in the context of this problem, right? Some exponential functions can't go any further back than 1, depending on the context. In this case, my turtle context. Any questions on that? Yeah, Christian?
It won't be like this on the test, right? Like,
It'll be bigger.
it won't be a fraction?
It might be.
Oh.
I thought you meant the size. All right, we got Jesus, okay. We're going to get through this quick. So my x values, I'm going to do our -2, -1, 0, 1, and 2, because that's what it's going to be on the test. I added a box. Because there's going to be an extra box. Okay, everybody stop talking. I take my x, I plug it in. 3 to the -2 is 1/9 times 2 is -2/9. Plug in -1, 1/3, -2/3. Plug in 0, that's 1, -2. Plug in 1, that's -6. Plug in 2, that's -18. Okay? So my points, 0, -2, right about there. -1, -2/3, right about there. -2, super close to 0, right about there. 1, -6, perfectly right there. 2, -18, all the way down there. So my line is going to look something like this. I'll do it in red so we can see it. Boom, 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 boom.
Yay.
Looks like that. Okay? End behavior. Let's take a look. As x approaches positive infinity, meaning as I go to the right, to the right, to the right, where is my red line dropping off to? Negative infinity. Down, down, down forever. As the x-axis approaches negative infinity, as I go to the left, to the left, to the left, what does my red line get closer and closer to? 0. If I translated this function 5 units up, what would be changing about my function? Alex?
You just add 5 to the end of your function.
Exactly. -2 times 3 to the power of x plus 5. That's 5 units up. Is that what you guys got? Cool. Number 10, plug in -2, 1/4 times 2/5, 2/20, which is 1/10. -1, 1/2, 2/5 times 1/2, 2/10, 1/5. Plug in 0, that's 1 2/5. Plug in 1, that's 2 4/5. Plug in 2, that's 4 8/5. Gross. So, what is wrong with this graph? This is the wrong graph, or these are the wrong numbers. Oh, it's because our A is so small. Whatever, we're going to make this one work. We'll try our best. 2 8/5. That's like almost 2. 1 4/5. That's like almost 1. 0 right there. -1, super small, even smaller than that. Okay, this is a really gross one. But whatever. It looks like that. Okay. What would happen if I took this f of x and did negative f of x? What would happen to it? It'll reflect over the x-axis. That's all. It'll go flip right down. Alex?
I put it is a reflection of f of x.
Yeah. Be specific. Over the x-axis. That's totally fine what you said. Just add over the x-axis at the end. Okay. End behaviors. As we go to the right, to the right, to the right, where's my red line going? It's going up and up and up, which is positive infinity. As I go to the left, to the left, to the left, where does my red line approach? 0. Nice and easy. Last but not least, don't look at my pants. Last but not least, describe the transformations that happen to each function compared to the parent function. F of x is equal to 4 to the power of x. So take a look. I got a negative and I got a 2. What does that 2 tell me happened there? Vertical stretch of 2. Thank you, Aaron. A reflection over x-axis. Got a lot going on over here. I got a 1/5. I got a -7. Gurpreet, what does 1/5 tell me? Vertical compression of 1/5. Alex, what does that -7 tell me?
Translation of 7 units down.
Translate 7 down. We did it. How confident are we feeling? Thumbs up, we're feeling very confident. Thumbs down, we're not feeling confident at all. Thumbs sideways, we kind of feel confident. Okay. Keep in mind you can always do test correct.